What the heck, bro? That's one of the biggest avalanches I've ever seen in real life. It's gonna pummel us. Oh my gosh. What? Dude, I hope nobody...
Hello guys and welcome once again. In this tutorial we will be learning how to do an avalanche, how to do cluster, how to do some wedgings and a little bit of rendering in Karma. So stay tuned and watch the full tutorial. Guys, do you want to join a really nice server? We have tons of different channels. We have effects, modeling, loop dev, compositing. We will have resources for every type of discipline. So hop in and have fun. I also have a Patreon page where you can support me. I have every single file, I have polls, I have even some tools, guidance. So if you are interested, you may have a look. Thank you. Okay guys, so welcome to the file. So this effect is very simple to create. There are a couple of steps. Begin with, the thing we got to do is to do the base of the mountain. I'm going to turn this on so we can see where we're going to go next. So we create a height fill, we create some noise. These are the settings, nothing too particular. It's just a noise. I painted somewhere where I have the mask. Let me show you briefly what I have the masks painted based on the camera, because we are going to be roughly looking somewhere around here. I painted and I'm remapping this with a mask. I computed the range and I started messing around with these ramps. As you can see, it can lower or rise or lower the height fill. Then I mask clear and I do a new mask here because I want to smooth it out. And this is my base mountain. This is what we're going to be using. Secondly, I go here and I'm also going to mask by feature where I want to have the what's the name, the erosion happening. I just inverted the mask, as you can see, the one we had before right here, and I started eroding. So we're going to go to this frame. By the way, I'm using this time shift because I don't know why the time shift inside the height fill erode wasn't working for me, but it's not such big of a deal. What I did here is to control the precipitation. I don't want any type of precipitation. And I increased the removal rate. Then I removed the river bank and the river bed because I don't want to have anything to do with that. And I post smooth the debris. That will make all of this a little bit smoother. Nothing else. The simulation starts on the 10:01 and the visualization, I change the visualization to these colors just so it looks a little bit like a snowy mountain. And this is the compute range button. As you can see, it's going to compute again. Well, I want to recalculate it because you already have the time shift. Then moving forwards, I do a mask clear and I do a new noise with a mask, of course, so we can have different parts doing different things. Then I did a mask by feature where I'm masking based on the angle or the slope. I resampled this so we can have more resolution. I added a new type of noise where I noised these parts a little bit, you can see. Then I mask by feature again. I have everything where I want the noise to remain on certain altitude where I want to have a terrace. So I created this noise with this slope, and I created another noise, not a noise, but I created another mask with another height. So it's slope multiplied by height, and it will give me this. And this is the terrace. Where this is where I'm going to have the terrace, as you can see. Then with this mountain, I'm going to be replacing the mask. Now we have the same mask that we had before, and I'm going to start to do a new height fill erode. This height fill erode, and let's go to the frame 10:10, I believe, because that's where I'm going to have it. I think it's the same erode, there's nothing different, but we're going to check. So no hydro erosion, a little bit more thermal erosion, no precipitation. This is the same as disabled, and I reset the debris layer, and this is where I use the masks on the erodibility on the thermal, and the hydro is 0. And I believe I did the same right here. on main, I did use the mask, which is here. Sorry if I was explained before. And then I cleared the mask, and now I have something like that. I'm replacing the mask again. I'm blurring this mask. I'm clearing this mask. Why? I don't remember. Oh, because I'm not blurring the mask. I'm blurring the height field. That's why. But once I blur the height field, I remove the mask, and I mask by feature again, and I noise it. This is my feature with the slope, and I noise it with a replace, and this is the noise layer, which is the mask. Otherwise, I would be having noise everywhere. These are some places where I want to have some more things going on. Or, in fact, we're going to be exporting this. So once that I have this, I'm going to time shift this to the front 10 of 10, and I'm going to file cache this. This is the mountain volume. As you can see, it's this volume. I'm saving it to disk, and this is the part where I created the mountain. This is what we have at the moment. So we're going to do a couple of things here. We're going to firstly export the mountain textures, and I'm going to just grab the mountain and do height field mask by feature to create some kind of a slope mask, just in case I want it. I don't know if you are going to be using it. And I height field copy the mask to the NY. This is not necessary. We could just not have this, but I wanted to do a small test using copnets. So I'm going to Control-C, copying the copnets right here. Then we're going to be using... Oops, I didn't have to turn this off. We're going to go into the compositing view, and we will see that if we stop import this right here, Control-V, this is what we have. We're going to import everything, and we're going to be using this resolution. It's going to be square. You can put whatever resolution you want. When it says custom planes, you will see that I'm grabbing the bedrock as a float 32, the mask as a float 32, the mess and everything mask, I'm grabbing it as as a float 32. And if you click here, this is where I removed it. If you click here and you create that plane from SOP, they will be linked here. So what did I do next? What I did here is to then do a channel copy, because I wanted to grab the debris and plug it into the color. We'll see if we go here and we just go into the sea. Now my sea is my debris. It could be, I don't know, my bedrock, for instance, but I want the debris. And I blur it a little bit. You will see that I'm blurring it. And then I'm exporting this as a heap text $.exr with the color and the alpha. You don't need the alpha. You just need the color. But I wanted to have it anyway. And I did the same for the NY. In case I need it, I wanted to do some tests. I don't think I ended up using it. Exported this. Exported both as NY and the rest. These are the textures. So let's go back into the scene view. In fact, let's go into build. And let's go into the mountain base. Let's go back again, show selecting nodes. So you will see this is the camera, and I'm converting this into a polygon. You will see we have a bunch of polygons all over the place. And this is the main geometry. We're going to be using it for some frustrums and some reductions. What I did here is to firstly go into the Pizola frustrum. This is a great node which I created. Basically, what I'm doing, you can skip this because I explain it on every single video. But what I'm doing here is to basically frustrum everything as shown. This is the part we create a box. If you see, this is on the positive. No, wait. This is on the negative Z and the positive Y. We're grouping the front, and we're also grouping the back. We're promoting these 2 points, and with a primitive we are enlarging a little bit the box. This is going to be enlarging the back of the front, as you can see. So basically I'm grabbing the group back, and I'm using this extrusion. We are basically just moving it on the negative Z axis, and with a simple point from NDC using the camera, I am transforming the points to a frustrum, and then I can do whatever I want. I could group and I could boolean and whatever. What I'm doing here is to just group if I'm not, yeah, I'm grouping. You can tell by this is not a boolean, it's just blasting the points. I'm grouping the points and I'm deleting them. After this, I'm poly reducing them 2 times. The first one is this one, and the second one is this one. So now we went from 500,000 polygons to just 135,000. And then I realized the scale was a little bit small for a simulation, so I increased it. I made it larger, 2 times larger in fact, and I moved the camera to. This number 2 is reflected on this null, as you can see. It's just a relative reference. Then the same I did here. This is the high resolution. I moved it here. I also did a frustum, and I grabbed, let me show you. I did the frustum right here, same, and I grabbed the distance from the geometry with the camera origin. This is the camera origin. I basically grabbed the camera origin and I did distance from geometry with the points, and I will remap this distance from whatever the number is to 0 to 1. You will see, if I turn on distance, this is how it looks. Red is in this case 1, and this is 0, other way around. And then I recalculate the normals, and this is my geometry. This is the geometry I'm using. I don't know why I have this, but I decided it could be cool to have some different refractions or whatever. And this is the geometry we are going to probably be injecting into Solaris. Going forwards, this is the proxy, and I'm going to do a little mountain. So this is very interesting. As you can see, I did something where I grabbed the points, and everything was set to 0.05 and then a little bit bump, because I wanted to keep the original mesh intact but only have bumps upwards. This is very convenient because what I'm going to do now is to create a grain simulation, and these are going to be like these little ramps where they can jump and be a little bit messy. So this is the first part. What I'm going to be doing next is to create the grain, to create the grain base. So basically using this and deleting everything, I'm going to paint a couple of masks. These are the masks. These are where we're going to be having our avalanche, and deleting everything as shown here. I'm going to pick it a little bit so it's just above the surface, and I'm going to scatter a bunch of points. This is enough for me. I'm also going to be doing something. We are going to be calculating the density. Let me show you. Where do we have more or less points, right? And if the density is less than 0.5, we're going to be deleted. As you can see, everything that's very sparse is going to be deleted. This was done because I wanted to separate these two guys. This was the solution I found. You can see, because I wanted different clusters. So I'm basically calculating the radii of how many points you calculate far from each other. How many points with a handle using the PC open, calculating the position, how far you are and how many points you have. You can calculate on how many points you found nearby and how many points is the max, and you can have a value from 0 to 1. So everything is going to be 0 to 1 basically, and if it's less than 0.5, it's going to be deleted. So half of the points that are near the edges are going to be deleted. We're going to be calculating BDB from particles, so these are going to be separated. We're going to be converting this, and we're going to be creating the names. This is just a simple class with this code. This is a name with text. This is a string plus the itoa of the class, so it's turning the number to a string. This will create a series of name attributes. Many of you already know, but we have small pieces floating around. So with a measure fracture, I deleted every single small piece and I just kept the big ones. You will notice, or you will be asking, how did I do this? Basically, in this case, I chose the bounding box. So what I did is to calculate the bounding box of each primitive called name, and I get the bounding box of the object itself, and I multiplied all of them. Then with a simple split, I say, hey, is your bounding box less than this number? Then split, go to the left. Otherwise, go to the right because you are big enough. So we have 1, 2, 3, 4, and 5. And I calculated the class again, as you can see here. This is the class. Oh no, this is the cluster, sorry. This is the cluster 0, 2, 4. And I'm transferring to the points the cluster attributes, which is here. Aha, so now this looks way better. These are going to be independent simulations. Moving forwards, I'm going to cluster the points. I'm going to do a grain, balloon from grains. This is what we have. We're going to color them to a red so it contrasts a little bit. I'm going to add a point velocity with curl noise, and this is kept incoming. This is the wheel size, and we can tell the velocity looks something like that. And I'm going to delete everything but the... No, we're going to just delete this so we stay on points. Then what we're going to be doing is to grab the collider, and the simulation is going to be run like this. Look at this. This is going to be the whole simulation, which from camera looks something like this. Remember, we're using this as a collider. You will see it collides. It has like a nice shape going downwards. You'll see it's kind of mixed in between, because what I did is to go into the advance, created the max acceleration, and have the repulsion 2.5 and the attraction to 1. That's all I changed, I believe. All the forces, all the wind drag is 0.01, and on the solver the substeps is just 2. I could be using more, and the clamps would be tighter together. If I go here, I don't have anything. So it's just a basic solver, nothing complex. But you will see, if I go here, it will just be... let me see. Yes. So we have the colors going downwards. Some of them are mixing, some of them are not. These are falling from the ground, but I don't really care about them because we're going to be deleting them after the fact. And this is a test. This is a test where I created the geometry, and this is where I started testing with a sphere and a balloon, how far or how fast this starts falling. So see, I'm testing how fast they look. Oh, I should be looking at this. So this, I'm testing the speed of the simulation with the spheres falling downwards. If I like it, I'm going to be changing this. Whatever. This is just to test, nothing else. This is the real simulation. And to finalize, what I'm going to do to make these clusters work is to grab the grains. This is the grain simulations. What I should be also be doing here is to actually time freeze this, because this will calculate each frame otherwise. But I forgot to do this. You shouldn't be forgotten. Just do a time shift and call it a day. What I'm doing here is to iterate per cluster on the points and create a meta import node so I can have the data that I need. The data that I need is the following. As you can see, this is a single simulation, but what I did is to wedge count the following. I'm grabbing this node right here, Control C, and just pasting it in this formula, getting the number of iteration and 0. That's all I did. Then created a wedge on automatic, and I'm listing in this case based on the wedge. This is what I'm wedging in, all with this back tick. This is I disabled the simulation in this case, but you shouldn't. I don't know why I did it. It should be turned on. And the scheduling, the CPU per batch is 1 minus your core count. So this should be the same as this. This is one way to do it. Other way should be going to simulation, turning one batch at a time, sorry, and then turning the simulation on. In this case, I decided to do differently. So this is how it works. This is where it's going to be saved, and I'm loading per disk. And you will see if I generate the static, you will have the points, and we can collect each simulation one at a time. You can do this either with the original Pyro tools or with action. In this case, as this is on a diagonal slice, it's going to be way better with sparse or with action. Try not to use legacy because this will be very slowish. I tried it and it didn't work. So I'm grabbing an ID per points. I'm frustum everything that's not in the viewport of the final camera, which is this one. I'm blasting all that's not the wedge, which I'm selecting. We can select it like this. You will see. Boom, boom, perfect. And then I'm creating a magnitude value to have the following. Let's look at this. This is the magnitude. So everything that's red is going to be interacting with the smoke simulation and creating a trail so we can have more points going on here. I'm adding this based on the ID and I'm resampling. This code, by the way, is just I'm creating the magnitude of the velocity from 0 to whatever I want to 0 to whatever I want to. This is a way to control my values of the magnitude, and all the magnitude will go from 0 to this value here. Then on the wrangle, the density is going to be equals to 1, and the biscuit is going to be the magnitude by the curve view plus 0.1. The curve view looks something like this, which is grabbed from here, from 0 to 1. And you will see when I group this with the extrusion of the proxy, all these pieces should be deleted. And we are only going to be staying with this at the top. We're going to background this. We're going to add a bit of noise. I went over the top with this. You can tell in the video there's a lot of swirliness. It's because of this. This should be at least the half. And well, I'm rasterizing these values. This is what we have. The density, velocity, and temperature. We don't have a temperature, but I decided to add it anyways. With the Pyro process, I'm just lowering the velocity vectors and the density to 16 fleet. I'm calling the velocity. I'm doing all this to just optimize everything out. And when I create this, I'm going to save in background so we can have all the wedges loaded into this automatically. So I also created a way to have bounding box where this is the previous step. I mean, this is the final step, and this is the step at the bottom, at the top, and I created a box. This is to create the limits. The limits are then driven in the Pyro solver. This is the wedge source, and this is the collider, and the collider was done just with a simple collision BDB. This should be filled too, which I didn't do it, but it doesn't really matter that much. Then if we go into the first frame, and we go into here, you will tell a couple of things. First, I'm limiting the bounding box because I didn't want to have a ridiculous large bounding box and nobody's going to tell if they clip at the edges. In this case in particular, so I'm limiting this like so. I'm basically having the bounding box and the X size, the Y size, and the Z size. You can just copy the code and the centroid of the same, but the X, the Y, and the Z. I'm just grabbing this one right here. So the limits is the same as the box right here. On the collision, I'm limiting the collision range to 1 frame because it's just 1 frame. The sourcing, this is the whole frame of this simulation. I'm doing this because I try to use it with GPU, and GPU this is necessary. This is the density by 4. There's no temperature, so this is the same. There's no flame, so this is the same. And the velocity is by 0.6. It could be even lower. On the fields, I'm just having the dissipation, the shape, I have the buoyancy, like so, gravity acceleration to 2. I'm using this field advection to BF, ECC, and clamp. The output is, I'm having these values, so it's a BDB. Then inside here, the only things I did is to use the gas disturbance to 250, block size of 16, because remember this is a really big simulation and scale-wise. And I'm grabbing the speed from 0 to 15 with this curve. The same here, in this case is rotational, and in this case is not, but this is block size of 8. And the turbulence is 2 and 16, and 3 of turbulence detail. And control settings is the same, speed, on the control influence is 1 because everything is going to be controlled by the influence. The same is here, but this is just a vortex confinement. I actually have 2 I should be having one, but I used to. I don't know why, but you should try to stay with one. What else? I think that's it. It's going to add a little bit of turbulence, and the disturbance is going to like break the shape as it flows forwards. So this is what I have, and the trick is exactly the same. It's exactly the same. In this case, all the wedges, and if I generate the static, well, I can choose between the simulations, saving background, and it will be all saving. I do have a something here, which is a way to pre-visualize this in the stage context edit 1, which is the resample. As you can see, this is way lower and this is way higher resolution. The resample is just a simple voxel scale only with voxel scale of 3. And this is the final step. We have the smoke, we have the mountain, we have the textures, we have everything we want. Oh, and this wasn't a simulation because this is just a source, because it's actually saved here. Finally, the last step of all of them is to create this stage context. So I'm grabbing the Avalanche, as you can see, right here. Let's go into a frame in a more advanced frame. This is how it looks. Nice. And I created a take. In the take, the only thing I'm doing is to go into this context and moving this switch to the right. You can include or exclude from take with right click. But this is the only thing I did, because when I'm using the take 1, I'm going to be using this as lower resolution, but I'm going to stay on main right now. I'm going to use a Pyro preview with these settings: density 0.3, shadow density 0.69. This is nothing, and the fairy, well, I tried to do a test here, but it doesn't really matter, to be honest. It's just this what we need. And I'm grabbing this, and the Avalanche is going to the Avalanche. You will see I'm very organized here. If we go into the Solaris context, it is very, very, very important to be organized. So I'm creating the scene, the environment, the background, and the volume, and the Avalanche. And inside the Avalanche is the Avalanche. This is how I created it. When you create a sub import, this is defaults, and this is what I did. I created the hierarchy. That's all I did. So everything is organized. And here the same. I saved the materials next to the object itself. So we are organized. On the mountain, I'm doing exactly the same, but instead of being a ball, it's just a geo, and the materials the same. So if we combine both, we have the geo and we have the volume, one next to the arrows. See how organized this is. And then we grab the camera. The camera is inside this scene, but it's on the camera. And the lighting goes to the lights right here, scene lights. So, but what do we have here? So we have the mountain. This is the out geo. This is what we are going to be seeing from the camera, which is the cam final. Let's go into here, cam final. And there we go. So this is on CPU. Let's hop into the material. This is quite like, okay. So the mountain is this material. It looks quite complex, but it's not really that complex. So basically I'm grabbing the position, I'm grabbing a multiply to increase or reduce the position. So to increase or reduce the scale of the texture, if we make this smaller, the texture will be bigger. I'm grabbing some textures. These are some albedos. These are some roughness, and these are some displacements, nothing else. And I'm remapping the colors just in case I want to remap them. And I'm doing the same for another texture. This will be, if I'm not mistaken, the snow. The snow will be two different materials. Let's just work with this on Karma. Let's remove the displacement and let's put this here. So this is how it looks. Let's hop into the downlight at least so you can see it. This is how it looks. This is the light. It's just a simple HDRI, and this is the mountain. There are two textures, even though you can't really tell because it's so white. But basically what I'm doing, if I remove one of these, you will see we are having something going on here. What we are having is that I'm grabbing the debris and I'm using the debris as a way to mix between the textures. I'm mixing between the textures. That's all I'm doing. I'm mixing the texture A, B, and C. The A and the B. And I'm mixing the displacements. I'm mixing the roughness. Well, the roughness should be in float now that I think about it. It should be in float, right so, because they are just a black and white image. And finally, I'm using the geometry property value, which is the debris, because I also have the debris saved into the geometry, right? We could have used, instead of this, the mask itself, but I wasn't getting so good results, so I decided to use the geometry instead. So let's look again into the dome light, and let's just ignore this for the time being, and let's see what happens. There we go. So as you can see, I'm just controlling where the debris is, and I'm making it a little bit darker. That's about it. I'm going to make this a little bit larger so we can see this properly. Let me move this downwards. Okay, so this is the first material. As you can see, we're mixing two shaders of snow, of course, and then we want to mix another shader, which is not this one. This is just a mask that I did, but we want to mix it with this stone shader. The stone shader is basically the same idea with a texture of a rock. This is it, with a ramp to change the values a little bit. If we do something like this, it will change to a reddish color. There we go. And what we do have right now, this is the one of the colors of the texture. We are separating the X position and setting, hey, you should go from -0 to 0.5, so part of the displacement go inwards and part go outwards. And the same I'm doing with this texture. Then I'm multiplying this by a certain value because I want to have different type of displacement values. I'm mixing these two on 0.5 and I'm powering this if I want to have more contrast. Then the displacement is getting mixed with this shader. The only thing this shader is doing, let me show you, is just differentiating between the masks that I want and the masks which I don't want. Let me go back, show you what this is. On the one hand, I have this, which is a mixture from it's this mask which I got from the vertical position. Basically I'm grabbing the normals from the position, is the mask which extruded, and I'm saying, hey, I want to use from 0.3 to 1, and then I want to remap this so I can have more contrast in the areas that I want. And this is sort of the mask with the slope. It's a different way to get a slope, and you will see it looks kind of distorted. It looks distorted because I'm adding the position like so. I'm making the position, multiplying, adding a simple vector to noise because this is going to go into the UVs, and then multiplying by a vector. And you can see if I add like, I don't know, 7, the noise will change. So I'm using this slow value just to distort a little bit the image I originally have. And then I'm just multiplying all of that with this. This is just the point information, if I'm not mistaken. Yes, this is the... Oh, this is the normal information. That's very nice. But sometimes you don't have the resolution you want in the geometry. This is the case here. I don't have enough resolution. So I wanted to mix it a little bit. So I'm basically grabbing the Y position. This is how it looks with the normals. You can see this is another way to get like the slope of your geometry, but this is point based. So you reshade it. I only want every single normal that goes in positively. Then I'm going into this ramp. Basically what I'm doing is to control how much do I want from one mask or the other one in terms of the shader. This is, remember, from 0 to 1. So Then I'm grabbing the color I do want to mask, and I do want the blue one to be the mask. That's why I'm grabbing this one. And it will look something like that. The blue will become 1, everything else will become black. I'm going to remap this to invert it basically, and then I'm going to multiply both masks between each other. Then I'm going to remap this again to re-invert it, because this was an issue I got going from previous versions of Houdini to the new ones. Once everything is done, we can use this mask to blend between the rocks and between the rocks and the snow. And then if I go into the camera, I can just add this here, and we will have displacement from the rocks and from the snow separately. That's it. Going backwards, let's turn on the avalanche. We have the camera, we have the dome light. The dome light is quite nice because, well, let me just turn off the displacement so it's faster. The light is very nice because we can just rotate it as we want. You'll see it all changes. I wanted this angle. And we're going to do a small check to render this in layers. I want the snow to be on GPU because it's faster, and I want the mountain itself to be in CPU. So this is the mountain. What I did is to hide everything from the scene and hide the primaries, and then on the second one I just chose the geometry, which is the mountain, and I turned it back on. So we will have the smoke doing a phantom and just rendering the mountain. On camera effects I have motion blur and I have depth of field. We could turn this off, to be fair, it will be faster, but I had it turned on. On limits I had these values to make it faster, but also have some volume limits. This is the renders I have, and I didn't change much else. Then if we go to the other side, what I did is to do the same trick to visualize the volume, but also the geometry to matte. I'm showing it and I'm matting it because I don't want it to matte when I'm going to render. This is interesting in the sense that we're not using the deep compositing, so this is the way to do it. And at the smoke, when we go and put the limits, which are 3, the smoke, once we load this loads into the GPU, will look like more bright because there's more like light scattering. Let's just wait for this to load, and look how fast this is, right? It's very, very fast indeed. And it's actually receiving shadows from the mountain, which is actually not being visible. Then we're just going to be exporting this with the take number 1. Remember the take number 1, because the take number 1, oh no, this is an error. We shouldn't be rendering with the take number 1, and we should be using this as the take number 1 because the mountain needs to receive the shadows from the smoke and in low resolution to make it faster. And in this case, we should be receiving we should be rendering the smoke in high resolution. And that's how it is. This is how this was done inside Houdini. I hope that you enjoyed it, guys. Thanks for watching the full tutorial, guys. If you liked it, please leave a like, comment, subscribe, and join the Discord. See ya.
What the heck, bro? That's one of the biggest avalanches I've ever seen in real life. It's gonna pummel us.